Hello everyone, in this video I'm going to be showing you how to cut this angled dovetail thingy because it is not as simple as one may have you believe. Now if you haven't already, be sure to watch my previous video, link is up here, to how to cut a standard through dovetail joint, because what we have here is an intermediate joint, and if you don't know the basics you're going to really struggle with this. And if your skill level is somewhere between cutting a through dovetail joint and something like this, in the description you'll find a link to 5 tips to instantly improve your dovetails. So, without further ado, let's get going. So we've got our 2 blank bits of timber here, but getting close because there's a few things to be said about this joint before cutting anything out. So when we join these together, the tails are going to be on the oven coal here, and then we're going to cut the pins on the ash here. But when you're sizing these components, if you have to fit this in a cavity that is, where's my ruler? How do I always lose this? Ah, there. So say if these were a drawer and I wanted a sloped front on that drawer for whatever reason, and the cavity was, what's the height of these? 85 millimeters tall. Therefore, the overall height of the drawer would also need to be 85. If you scale these to be 85 millimeters exactly, bear in mind that by the time you slope that back, you've lost a little bit of height on the top here, and that depends on whatever angle you put on the front of this drawer. So make sure you take that into consideration, but the first thing we're going to do now is cut the 30 degrees onto the end of this component. So tilt the bed to 30 degrees, get it locked down and send it through. Now, do not chuck this bit away. You can actually use that later on when laying this out. So there we go, that's sloped. So now we can angle this back, and you can see that the next bit we need to pay attention to is this corner here, because that is not sitting flush on the workbench when we lay it down like that. We also need to plane this to 30 degrees. So if you're feeling confident, you can do this by hand, no problem with that whatsoever, but I'm going to do it on my planer because I have it available, and why wouldn't I use it? So that is now locked to 30 degrees, which matches the exact angle of what we've got on the end here. So let's go to the planer, and then we'll match the angle of this fence to suit that. You could also just use the component for this step as well. And we're going to plane one of these edges to match that angle. Now when we were planing this angle, we weren't particularly referencing off anything other than this face, so there's no guarantee that these edges are now square to this edge, which obviously we want. So we need to cut them on the miter saw again, get them back to 0, making sure that this angled face is pressed against the fence behind. Okay, and then let's get the top sorted out. So this angle part here needs to be the same height as this lower area here, so we can simply trace that on like that. And then we know at the end of this ash one, that needs to be parallel to this edge here, so it's going right from that corner. And I'll just draw it on roughly for now. So then we'll set the fence up to hit that line, or just on the way side of it. There we go. And then send it through. Okay, pop that over there, and then as for the angle piece, we're going to need to angle the bed to 30 degrees as well, so we'll use the sliding bevel for that. Then we'll use this setup to take out the bottom corner of that component. So there we go, there's the angles cut. So on the bottom we've got our clean faces, and then the top ones are the rough sawn faces from the bandsaw, which we can clean up later on. I used a bandsaw for this because it's the only thing I have available, but if you have a table saw it would be far more accurate and a lot easier to clean up this top edge if it were a table sawn edge as opposed to a bandsawn edge. I'm just working with what I got here. So to start with, we're going to mark the baselines onto the corresponding components. So set a marking gauge to the thickness of the ash we've got here, and then transfer that onto the tails. So we'll just do the front and back with the marking gauge for now. The reason for that is because it's difficult to get it on these edges and keep matching that angle, especially on this one here, because it tips back and then it doesn't quite reach it. We're going to square those across. So then set the marking gauge to this one, and then on the pin side or the socket side you only need to mark the front and back anyway, so we'll make that nice and deep on the inside face, and then not as deep on the outside but still pretty prominent. So get it in the vise and square these edges round. So you can pop the knife in the line on the back edge, and once it's in there, slide the square up to it and you know it's spot on. And there we go, there's the edges marked out. Now in terms of marking out the dovetails on the end of this is the bit that you'll find tricky, because you'll find that if you set your sliding bevel to a standard 1:8 ratio and then start marking things out like that, you'll see that the dovetails will end up being way too steep, and by the time you cut them out, it'll end up looking like this. Because what you've done here is made the dovetails correct in relation to the end grain, but not in relation to the actual wood grain itself. So in effect, what you've got on the side of these tails here is what looks to be like a 1:1 ratio. So you've got some incredibly short and fragile grain on these corners here. And if I was to hit them with a hammer, you can see you can easily just break them off like that. They're extremely fragile. Now, if you're not entirely sure what dovetail ratio to use for your next project or joint, whatever, have a look at the video I've put up here, because it'll help clarify the things you need to look out for when selecting what ratio to use, but more importantly, bust the myth that you need to use certain ratios for certain jobs. You have a lot of scope that you can choose. It's just knowing the advantages, disadvantages and consequences of choosing each ratio. So let's continue marking this one out. So to start with, I'll just get the spacing sorted. So I'm going to make it 6 mm in from either edge, and I'm going to do 2 dovetails on there. So I'll have a little gap between them in the middle there. So to get the ratios right in relation to the grain here, it's incredibly difficult to do, because like I say, you can't really do it from the end grain, because the closest you can get is kind of setting it by eye, but then by the time you flip it over the other way, it's completely wrong again. You could potentially, if the board was narrow enough, you could try and set them up from the sides maybe, but probably not in this case. This is the reason we've kept hold of this little bit here. Oh, I've just snapped. What we're going to do is set a 1:8 ratio on this sliding bevel. Now, if you want to know how I created this 1:8 ratio, again, that video that I just recommended will show you how to do it. The link for it is also in the description. So if you missed that card in the top corner, you can also follow it through the description. So I've drawn a 1:8 ratio on here. And then what I can do is set the sliding bevel up on the 30 degree that I've cut on the bottom here, and then line it up with that 1:8 ratio that was referenced off this edge here. So you'll see that initially I referenced the sliding bevel off here to mark the 1:8 ratio. Now I'm referencing it off this 30 degree face here. And then you'll see when you put that on here, you have got a 1:8 ratio that is correct in relation to the grain. The only problem being, when you flip it around this way, it's now way too steep, which is why I've drawn 2 sets of ratios in here, because you're going to need to reset this sliding bevel to alternate between the two, or it makes it a little bit easier if you've got 2 sliding bevels in the first place. The other thing you can do, if your sliding bevel has a dovetail ratio in the blade here, you can actually set the sliding bevel to the 30 degrees like that, and then simply mark it down like that. You'll see that the dovetail ratio is still correct in relation to the grain, but not all sliding bevels have this. This is a Bridge City sliding bevel I've got here, and I have filmed a video on this, but it may or may not be released yet. If it is out, I'll put a link in the top corner now, and if not, then keep your eyes peeled. Now, before going ahead with marking these ratios onto the end of this component, what you've also got to be aware of is the illusion that this creates on the actual dovetails themselves. If you slope both sides of these dovetails to 1:8 ratio, one side of the dovetails will look pretty good, but then the other side won't quite look sloped enough, and that's demonstrated by this bit here. Both of these edges are a 1:8 ratio in relation to the edges and the grain and everything like that, and you'll see that these sides of the tails look pretty good because it's still got an acute angle on here, which is similar to what you'll see on any standard dovetail. However, this side here, because it's an obtuse angle, or in other words wider than 90 degrees, it kind of makes it look like that side of the dovetail isn't as steep as this one here. For this reason, what I tend to do is mark these out at 1:8 on this side, and then make this one a 1:6, so it's a little bit steeper. It's still an obtuse angle, but having a little bit of a sharper edge in there makes it look a little bit more even across the whole dovetail. Of course, this is personal preference, there's no need to do this, but it's just something I've noticed when cutting out this joint. So let's get these marked out. So starting from this acute end here, we're going to mark the 1:8 ratios. And then on these sides, we need to get the 1:6 worked out, so I'm just going to draw that on our angled block as well. Reset it to that 30 degree side, and then draw that on here. And of course, mark the waist on the front so we don't cut the wrong side of the tails. So then square these across the top. And then we'll get cutting these out down to the baselines. And if you struggle with sawing, I did a video on this called How to Saw Correctly. The link is in the top corner now. You'll pick up some great tips from that video, and it will help you tremendously with cutting hand-cut joints. So there you go, you might be able to see the difference in them now. This is the one that was cut at 1 in 8 on both sides, and this is the one that was cut in 1 in 8 on one side and 1 in 6 on the other. You'll just see that these ones look a little bit more dovetaily than the ones on here. So now to clean out between the tails, and we're going to do that with a nice sharp chisel, and you'll notice where I'm standing, I'm looking along the shoulder line so I can see if the chisel is going in straight or not. This is something, as well as many other tips, that I detailed in my video how to chisel correctly. Because as basic as it sounds, there are a lot of techniques and things that will really help you when it comes to your chiseling and make your work a lot more accurate. So I'm going to halfway, flip it over. When I'm chiseling back to this line, I'm getting as close to it as I possibly can with the chisel before putting it into that final line, because if you commit to that straight away, the chisel gets pushed back below it and you end up getting a nice old gap in this area here. So right now we're about 0.5 millimeter away, which in most cases is close enough. So pop the chisel in there, hit it vertical a bit, and then I'm going to angle it away ever so slightly and put an undercut to halfway. Also, be very wary of these acute corners here, because it's very easy to accidentally bruise the inside of this tail with the chisel. This is the inside face, so it's not too problematic if I bruise that edge, but on the opposite side here, we need to make sure that that is very, very clean. So now we're going to take it around to the vise and get these edges sorted out. Now with these, you've got to be very wary about grain direction, because on one of these edges, we're going to be cutting with the grain, so it's not a problem whatsoever. However, on the opposite face, as I'll show you in a minute, we're going to be cutting against the grain, so we'll need to attack it in a slightly different way. So same as usual, we're going to take off as much as we can and get as close to that line before committing to it with the chisel. And then when I'm hitting this, I'm looking at it on the back edge here to make sure it's going down this line nice and straight. There we go. Now this is going to be the problematic one, because as I said, we're going to be going against the grain here. If I chisel down into that, the chisel's going to want to sort of get into that end grain and follow it down, and then it might potentially split up that surface there. Got to be very careful on this corner. So for this corner, I'm going to do a technique that David Charlesworth uses, I believe, which is called tenting. Kind of sounds like an odd activity you'd participate on a Saturday night, doesn't it? So what you do with this is put the chisel into the gauge line, and then you angle it up ever so slightly, so it's not cutting directly across the component, but it's going to create a little peak in the middle. Then we'll go in perpendicular on this edge, and then the back edge as well. And then what that's done is create a little peak in there, and we'll remove that very, very carefully, taking off minimal amounts at a time. If you take off too much here, the chisel's going to dive into the grain, and you're going to have a nice gap or split or something going on. Your aim here is to get rid of that peak without touching any of these edges that we've just pared down. This does take a very, very sharp chisel to do this, and a lot of precision and care. Once you start approaching the bottom, it's really difficult to not hit those edges while still taking out the peak in the middle. If you do really struggle with it, get a smaller chisel and ever so slightly undercut the inside face. You don't need to do it a lot, just put a small dip in there to make sure that there's no peak left, but make sure you don't hit those edges. And to get rid of that bit of rubbish in the corner, simply press the chisel against the edge of the tail. Now you can just give it a small tap, and then in from here, and then I'll use a knife to get rid of the remainder bits. So now it's time to transfer the tails onto the pin board. So we're going to clamp the pins in the vise, and I'm going to set up a square behind it to be a similar height. Lock that down, put that on there, and then on the flat face that we've got on the bottom here, get a chisel and we can line up the tails with that. So then I know that it's flush on this face here, the corners meet up and the corners meet up on that face as well. Get a knife and very carefully trace around them, being careful not to let them move. And then we'll transfer those knife lines down to the baseline. And just for the record, that split is already there. It's not caused by anything that I've done, hopefully. Serves me right for using scrap timber, doesn't it? Luckily, this tail is going right over it, so it's going to hide it. Then we'll very carefully cut to these lines. And then working in from both sides, very carefully clean it up. The only bits to look out for when you're doing this is chopping out these bits here, because when you're chiseling down, you're going to start hitting the inside of the pins like that. So my advice here would be to work back to it as normal, but just do very small taps. So there you go, now chisel's in that line. I'm just going to give it one tap like that. You see we've still got all the waste bunched up in there. I'll do the same for this one. We'll put it upright in the vise and come in from the side like this and just carefully wiggle that chisel through. So now on the backs of the tails, I'll put a very, very small chamfer that's going to help them locate in the pin sockets. The chamfer doesn't start right at the top corner. I'm starting it about 3 or 4 mil down from that. If you start it from the end grain, then you'll get a nice 45-degree gap in your finished joint, which won't be nice. Right, let's have a look, shall we? Okay, well, it's starting to locate in there. Let's see what we can do. Looking good. We've got a small gap at the top here, which I'm not entirely happy with, but I feel like I could probably do something with that. Otherwise, the rest of the joint looks very good. I suspect that if I glue this up and then do some strategic planing, I should be able to close up that gap quite nicely and make it difficult to see. Right, so I've let that dry for a couple of hours now and it should be ready to get planed. So all I did was just put some clamps directly pressing onto the tails like that. So where was this gap? It's down the bottom here. So when you get a small gap like this, a way to get rid of it is to actually plane the end grain so that it breaks out into that gap and then helps to fill it. Obviously, if the gap is massive, then that breakout is just gonna literally tear up the end of these tails and you're gonna get a new gap in there. Because this is a relatively small gap, the end grain will kind of just spread as opposed to split. So I need to plane in that direction there. So I've got no cut on my plane at the moment. I'm just going to keep bringing it out until, there you go. So let's start getting it flush. Just taking off very small cuts here. Now, a lot of you are probably thinking what this white stuff is here. I have absolutely no idea. When I bought the oven coal, which is what this brown wood is, it had these white bits going all the way through the end grain. So this literally goes right the way through the tree. I was going to use it for the guitar that I built recently, but that's why I knew oven coal because this stuff would have just ruined it. There we go. I think that's done it. Let's get a bit more. Yep, nothing there whatsoever anymore. End grain is just slightly spread out and it's filled that gap. Just get the rest of it a bit better. Okay, and then this face here, same thing, we want to plane this end grain in towards that gap that's been formed there. There's no gap along this top face, it was just on the front face here, but we might as well. Oh, there you go, see the white coming through now. Cool, there we go. Now we're just going to flush off the top, get that all smooth, and then this joint will be done.